Hello students, welcome to a new lecture of P block elements. In the last class we have seen the compounds from chlorine, which is nothing but chlorine gas, right? The next compound of chlorine is HCl, hydrogen chloride. How chlorine it is in the form of a gas just like this. Even HCl, hydrogen chloride is also in the form of a gas, right? The HCl as an acid which we are using is a solution which is obtained when you dissolve this HCl gas in water. So you get HCl in the form of liquid which is acting like an acid, and the name of this HCl which is in the form of liquid is called as hydrochloric acid. But the name of this HCl gas is hydrogen chloride only, right? So now let us look at some of the preparations of hydrogen chloride and its properties. Preparation of hydrogen chloride. Hydrogen chloride means HCl in the form of a gas. For every compound we have seen its preparation first, then its properties. Same has to be done even here. How can you prepare HCl? Is by taking NaCl salt along with dilute sulfuric acid. NaCl salt along with dilute sulfuric acid. When you take this combination, you get hydrogen chloride plus NaHSO4, sodium bisulfate. This sodium bisulfate reacts with HCl to give you this sodium bisulfate reacts with another NaCl to give you Na2SO4 plus HCl. So this is how you get hydrogen chloride by taking dilute sulfuric acid. You get two types of salt. One salt is sodium bisulfate and this is sodium sulfate. Sodium bisulfate means NaHSO4, just sulfate means Na2SO4. These are the preparation reactions of hydrogen chloride. It's not that important, its properties are important, right? Now we will look at its properties first. Now let us look at the properties of hydrogen chloride. Hydrogen chloride, what is the nature of hydrogen chloride? It has very high solubility in water. That means if you dissolve hydrogen chloride gas in water, it has very good solubility and it acts as an acid. Why? Because if it is dissolved in water, it releases H plus ions, which is the work of every acid. The acid is the compound which releases H plus ions, right? So we are calling HCl as an acid. Why? Because whenever you dissolve HCl in water, H3O plus Cl minus, which is what is this? Nothing but protonated water, which is nothing but H plus ions only, right? So by this action it is able to release H plus ions in water, therefore it is acting like an acid. It has a very good dissociation constant which is around 9, therefore it is a strong acid, right? Next property is it can react with a base also. Example of base we have taken is ammonia. If acid is reacting with a base, what do you get? You get salt, right? So same way, if you take HCl as an acid and NH3 as a base, you get which type of salt? Ammonium chloride salt. Ammonium chloride salt, right? Next is when HCl is taken in combination with nitric acid, in which ratio? 3 parts of HCl and 1 part of nitric acid. If you take 3:1 ratio of HCl and HNO3, what it is called as aqua regia. When you take aqua regia with noble metals, what are the noble metals? Gold and platinum. These type of metals don't react much. They are less reactive metals, right? So when you take noble metals with aqua regia, you get the complex compound of that metal. Coordination compounds of that metal can be obtained. What is present? What is aqua regia? Is nothing but what? NO3 minus ion is present, H plus ions are present, and Cl minus ions are present. So many H plus, so many Cl minus, and so many NO3 minus ions are present. When you react aqua regia with a noble metal, noble metals are taken here as gold and platinum. What do you get? You get a complex of gold, pentachloride orate. Orate is the name of the complex. Au is getting, gold is getting, coordination sphere has negative charge, therefore the name of the complex is called as orate, along with nitric oxide plus water. How many we are taking here? 5. So you take 5 chlorines. How many hydrogens? 2 there. So here also let us take 2. How many gold? Here. NO is right, but oxygens are 1 and 2. You are taking 3. So what do you take? 2NO. So that's how we will balance the reactions by hit and trial method. It's not that difficult. But what is important here? You get a complex of gold. Gold was actually unreactive or less reactive, but because it is dissolved in aqua regia, you are getting a compound or a molecule from gold, its complex. Same way, even platinum also can give you a complex of platinum 6 chlorate having 2 minus charge. Same way the remaining products are also same with nitric oxide and water. The noble metals which generally don't react will react with aqua regia. What is aqua regia? 3:1 ratio of hydrogen chloride and nitric acid, or hydrochloric acid and nitric acid is the aqua regia mixture. You, for 2 marks you may get what is aqua regia, show its reaction with noble metals. You have to define what aqua regia is and you have to write these 2 reactions, right? So next let us go to the next property of hydrochloric acid. It reacts with water, it reacts with base, we have seen. Now it also reacts with salts. With whichever salt it reacts, it will displace the ion from the salt with its own ions, right? So in HCl what is present? H plus Cl minus, right? Whatever ions are present in the salt will be removed and H plus ions will come in the place of this, right? So you get a different type of compounds and the salt will be some other salt. Is it a displacement reaction or not? H plus ions are displacing Na plus ions from this salt. Same way, what is the name of this salt? Sodium carbonate. From sodium carbonate, Na plus ions are displaced by H plus ions. Same way, from sodium sulfide, Na plus ions are displaced by H plus ions. From sodium sulfide, Na plus ions are displaced by H plus ions. Right, now let us displace that and get a new salt. So H2CO3, what is the name of this? It is acid. Which acid? Carbonic acid. Plus what is the compound? NaCl. How many NaCl you can get? 2 NaCl. Take 2 HCl. Same way, sodium sulfite if you take with HCl, hydrochloric acid will give you which acid? Sulfurous acid. Plus what is the new salt you got? NaCl only 2 times. Same way, if HCl reacts with sodium sulfide, you get what? Hydrogen sulfide gas plus NaCl salt. How many Na plus? 2. So how many sodium chloride? 2. 2 hydrogens from 2 acid and 2 chlorides, right? So in all the reaction, acid is displacing the ions present in the salt to give you new acid and new salt. This is salt, this is acid, but now this is becoming acid, this is becoming salt. It is displacement reaction. Who is undergoing displacement? Who is doing that displacement reaction? Is hydrochloric acid. These are some of the reactions of hydrochloric acid. Now we have completed compounds related to chlorine. Now we will see interhalogen compounds, right? Interhalogen compounds we have already discussed in not that detail. Now let us look at them in detail. What does interhalogen compound means? From halogens, what are the halogens we have? Fluorine, chlorine, bromine and iodine. These are 4 halogens we have. Fluorine is at the top, has highest electronegativity, and the remaining don't have that much electronegativity, right? So, interhalogen compounds means the combination of 2 halogens in which the central atom from that compound is lower halogen and the surrounding atoms are higher halogens. The central atom are, or you can also call it as, in interhalogens the central atom will be large halogen, large size halogen. Central atom, what is the central atom here? A is the central atom. Which halogen you should take as a central atom in interhalogen compounds? Means large size halogen. In between these two, who is large size halogen? Chlorine is large size. In between these two, who is large size halogen? Bromine is large size. In between these two, who is large size? This is large size, right? Same way, in between these two, who is large size? Bromine. In between these two also, iodine is large size. Large size should be in the center and small size should be at the corner. Large size should be taken as the central and X is nothing but small size halogen, or more electronegative halogen should be surrounding and less electronegative halogen should be in the center. So, you can get interhalogen compounds by having a general formula of this combination, one lower halogen, one higher halogen, or else this combination also, or else this combination, or else even this. In this halogen, interhalogen compounds, what is the oxidation state of the central halogen? +1. Because obviously this is more electronegative, it has -1. So, on A, the oxidation state will be +1. How many examples can you take for AX type of interhalogen? Who can be A? This can be A. Chlorine can become A with fluorine. Same way, bromine also can become A with fluorine. Same way, iodine also can become A with fluorine. Or else, next, with chlorine, bromine can become A with chlorine. Iodine can become A with chlorine. Same way, iodine and bromine also I can take, right? These are different interhalogen compounds we can have, in which who is more electronegative in between? This is more electronegative, this is surrounding. Who is the central? Chlorine. Less electronegative is chlorine. What is the oxidation state of chlorine? +1. What is the oxidation state of fluorine? -1. Same way, what is the oxidation state of bromine? +1. Fluorine is -1 because it is more electronegative. Fluorine -1, iodine +1, chlorine -1, bromine +1, chlorine -1, iodine +1, bromine is more electronegative, -1, iodine is +1. These are mono interhalogens. Now, what is the next combination I can have? AX3. Interhalogen compounds are also very important for your exam, okay? Next formula is one atom, one halogen in the center and 3 halogens are surrounding it, in which who is more electronegative? This is more electronegative. Who is less electronegative? This is less electronegative, right? So, what I can do? Less electronegative chlorine can combine with fluorine. Less electronegative bromine can also combine with fluorine. Less electronegative iodine can also combine with fluorine. Same way, you do the same. Br, Cl3, I, Cl3, I, Br3. In this type of interhalogens, what is the oxidation state of more electronegative fluorine? -1, -1, -1 means -3. So on this, on A the oxidation state will be +3, right? Same for all. Next interhalogen is AX5. In AX5 also what can be A? Chlorine, bromine, iodine will be A and fluorine becomes X. Chlorine F5, bromine F5, iodine F5, so on. In this, what is the oxidation state of these halogens? -1, -1, -1, -1, -1, total -5. Therefore on A +5. So oxidation state of A is +5. In the beginning we have seen the oxidation states of halogens. It shows +1, +3, +5, +7 oxidation states I told, right? This is the proof. Okay? It is showing +1 as well as +3 as well as +5, and in AX7 it will show +7 oxidation state, -1, -1, -1, -1, -1, -1 and -1, total -7. Therefore on A it will be +7. What can be the formula of AX7? Same, Cl F7 Br F7 I F7, right? Now we will see if this type of interhalogen is present, what is the shape? This type of interhalogen is present, what is the shape? What is the shape for these things, right? The best way to calculate the shape of any molecule is to know its hybridization. But before knowing hybridization, you should know how many electrons are present in the central atom of any molecule. If you know the central atom electrons of any molecule, you can easily get the hybridization as well as shape, right? In this, who is the central atom? Halogen only, right? For halogen, how many electrons it has? Total 7 electrons. It comes under 7th group or 17th group. Its configuration, if you remember, was NH2 NP5. That means it has 7 electrons present in its valence shell. Only 1 electron left to get its octet, we told, right? That means how many? 7, right? So let us take 7 electrons in its valence shell. 1, 2, 3, 4, 5, 6 and 7, right? For AX, I am calculating the shape. If you want, you can by heart the shape and practice the diagram. That also you can do, but the best way is to calculate by your own self to get the correct shape. Otherwise, you will read so many shapes and get confused, right? For AX7, who is the central atom here? A. How many electrons A has? 1. With 1 electron, it form a bond with X. 1 lone pair, another lone pair, another lone pair. So total it is having how many bonds? How many sigma bonds? 1 sigma bonds plus 3 lone pairs. Total how much? 1 plus 3. Total value is 4. That means for 4, what is the hybridization? sp3. Hybridization is sp3. The shape should be tetrahedral, but as it is only this way, the shape is linear with how many lone pairs? 1, 2, 3 lone pairs. Okay, the shape is linear. Why? Because if there was 4 bonds, then we would have said that the shape is tetrahedral. Okay, now what you should say? sp3 hybridization, shape is linear because it is having only 1 bond. Next we will go for which interhalogen? AX3. From AX3 onward it becomes very easy for us. Who is the central atom here? Same halogen. How many electrons will it have? 1, 2, 3, 4, 5, 6, 7. These are electrons, okay? Instead of that you take a star otherwise. 1 electron, 2 electron, 3 electron, 4 electron, 5, 6, 7. Because that X, you might think that it is halogen, that's why I am taking it as a star. First 7 electrons. First electron makes a bond with 1 halogen, second electron makes a bond with another halogen, third electron makes a bond with another halogen, because there are 3 halogens, right? Left over 1 lone pair, another lone pair. So how many bonds? 1, 2, 3. 3 sigma bonds plus 2 lone pairs. Total what is the value? 5. For 5, what is the hybridization? sp3 dehybridization. sp3d hybridization means what will be the shape? The shape will be trigonal bipyramidal. Who is in the center? A is in the center. Who are at the corners? This is the actual shape of trigonal bipyramidal. The shape of AX5 is trigonal bipyramidal. In the exam, they will not ask you what is the shape of AX3. Directly what they will ask, they will take any example. They will ask you what is the hybridization and shape of IF3 molecule. Means IF3 means you should immediately recognize that IF3 comes under this formula. For this formula we have already calculated the hybridization and shape, which is trigonal bipyramidal. But it cannot be trigonal bipyramidal because there are two lone pairs and 3 bonds, F, second F, third F. Now you tell me what is the shape of the molecule. Leave the lone pairs and you judge what is the shape. Is it a T shape to the molecule or not? Leaving the lone pairs, you see what is the shape of the molecule. Molecule has T shape. So you write T shape. T shape. The shape of the molecule is T shape, right? Now shall we go for the next interhalogen? What is the formula of next interhalogen? Is AX5. In AX5 also, who is the central atom? In halogen only, AX5, right? Here also how many electrons? 7 electrons. 1, 2, 3, 4, 5, 6, 7. Out of 7 electrons, 1 electron form a bond with one halogen, second form bond with second halogen, third with third halogen, fourth with fourth halogen, fifth with fifth halogen. The remaining 2 becomes one lone pair. So now how many sigma bonds? 1, 2, 3, 4, 5 sigma bonds plus one lone pair. Total what? 6. 6 means which hybridization? sp3d2 hybridization. What is the shape of sp3d2 hybridization? Octahedral. Who is in the center? A. X, 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 X. 4 are over on the square. Where is the fifth one? This. Where is the lone pair? This is the lone pair. If you leave the lone pair, which shape can you see here? It is square, pyramidal or not? Yes. So the shape is square pyramidal because you should not consider lone pair if it is present. The shape is square pyramidal, right? Now shall we go to the next? Don't think that 5 halogen means the shape will be trigonal bipyramidal. No. After calculating the halogen only you should get the correct shape. After calculating hybridization only you will get the correct shape. Now what is the next interhalogen? Questions from these will come as 2 marks. What is the shape of this interhalogen, that interhalogen, what is the hybridization? It is quite commonly repeated question in previous model papers. Okay. So now this interhalogen is very important for 2 marks. Next interhalogen is AX7. Same. How many? 7 electrons. Out of that 1, 2, 3, 4, 5, 6, 7. All the 7 is forming 7 bonds with 7 halogen. 1, 2, 3, 4, 5, 6, 7. So total 7 sigma bonds. There are no lone pairs. That means the value is 7. What is the hybridization? sp3d3, which means pentagonal bipyramidal. 1, 2, 3, 4, 5, 6, 7. In the center, iodine. Which molecule I have taken as an example to draw the shape? IF7. Have I taken the correct example or is it wrong? Instead of taking AX7, what I have done? I have taken IF7. Here also instead of taking AX5, I would have taken IF5 also is correct. IF3 is also correct. IF is also correct. Not just IF. any halogen combinations you can take, but it should be correct combination, right? So what is the shape here? Pentagonal bipyramidal. Hybridization is sp3d3, shape is pentagonal bipyramidal, right? Now these are about interhalogens. By this we have completed 17th group. Now the next group is 18th group elements or noble gases. Okay.